Motion and measurement. Lesson preview. The evolution of transport. Motion and its types. Objects having more than one type of motion. Measurement. Physical quantities. Standard units of measurement. Multiples and submultiples of units. Correct measurement of length. Measuring the length of a curved line. With the changing times, transport has also gone through various modifications, i.e. from animals to the invention of a wheel. The evolution of transport is evident when we observe the fast vehicles such as cars, ships, aeroplanes, etc. The evolution of transport. In olden days, people used to travel from one place to another on foot. There were no other means of transport. Later on, people started using animals both for traveling as well as carrying goods on their back. It used to take a long time for people to reach their destination. Then boats were used to travel across rivers and seas. The idea must have struck the people when they saw logs of wood floating in water. Early boats were made by simply hollowing out logs of woods. Later, people learned to make boats by joining different pieces of wood to make proper boats having streamlined bodies. A revolutionary change in transport was brought about by the invention of a wheel. Carts and chariots pulled by animals came into existence. This resulted in a faster means of transport. A major change in the means of transport was brought about by the invention of the steam engine. Trains pulled by steam engines were introduced in the beginning of the 19th century. Ships using steam engines were also built. Gradually, efficient engines which use petrol, diesel, and electricity replaced steam engines. Aeroplanes came into existence in the early part of the 20th century. Today, we have electric trains, monorails, supersonic aeroplanes, and spacecrafts. They are the gifts of the 20th century to help us travel faster. Motion. Just take a look around standing outside your house. You will see many things moving around, people walking on road, birds flying, dogs moving around, leaves falling from tree, a driver driving a bus, an ant crawling on the ground, a butterfly flying, clouds moving in air, etc. All the things mentioned above show motion. Thus, it can be said that when a body changes its position with time in relation to stationary things in its surroundings, the body is said to be in motion. When considering whether a body is in motion or not, we take stationary objects such as houses, trees, poles, etc. on the Earth's surface as reference. A body is said to be at rest when it does not change its position in relation to the surrounding objects with time. Different objects show different types of motions. A clock, a sewing machine, an electric fan or a swing do not move from place to place. Only parts of their bodies show motion. Let us now study more about the types of motion. Types of motion. Translatory motion. Translatory motion is that motion in which all the parts of an object move the same distance in a given period of time. For example, bus or train moves as a whole. Translatory motion is of two types, rectilinear or curvilinear motion. Rectilinear motion. When an object moves in a straight line, for example a train moving on track, a car moving on a straight road or children running on a straight track, it is said to be in rectilinear or linear motion. Curvilinear motion. When an object moves along a curved path, for example a stone tied to a string, and whirled along, or a car moving along a curved path, it is said to be in curvilinear or circular motion. Rotational motion. When all points on a moving object move about a fixed point or an axis of rotation, it is said to have rotational motion. Example, motion of the blades of a fan, a spinning top, rotation of the earth on its axis, the hands of a clock, merry-go-round, etc. Periodic motion. In some cases, the object repeats its motion after a fixed time. This is called periodic motion. Examples: motion of a clock pendulum, motion of Earth around the Sun, motion of Moon around the Earth, motion of a swing, motion of the needle of the sewing machine, a branch of tree moving to and fro, string of a guitar being plucked. Activity: take a ball or a heavy object, tie a thread to it, hold the free end of the thread, and let the ball hang down. Give the ball a gentle push. Observe what happens. The ball will continue to move to and fro from its position of rest. The objects which repeat their motion, but not at regular or fixed interval of time, are said to have non-periodic motion. Examples: blinking of eyes, swinging of hands while walking, running of a batsman between the wickets, etc. Oscillatory motion. This is a special type of repetitive or periodic motion in which the object moves about a mean position. The motion of a pendulum is a form of oscillatory motion. Its mean position is the position of rest and it moves on either side of this mean position. Objects having more than one type of motion. An object can have more than one kind of motion at the same time. Example: a rolling ball rotates as well as moves forward on the ground. Thus, the ball undergoes both translatory and rotational motion. Similarly, the wheels of a motorbike undergo both rotational and translatory motion. In a sewing machine, the wheel moves with a circular motion, rotational motion, while the needle moves up and down. The needle undergoes periodic motion. The change in the position of an object with time can be measured through measurements of distance. Measurement. We all make measurements in our daily life. When we go to buy cloth, we need to know how much is required. We need to know how far the school is from the home to decide on whether we need to take a bus, a rickshaw, or we can simply walk down. We need to know how much time it will take for us to complete our work. Our body temperature indicates whether we have fever or not. For traveling, we need to know the distance between two places so that we can estimate the total time of the journey. Sometimes, we have to measure a curved line. We use a thread to measure it. Thus, measurement is an important part of our daily life. Physical quantities. What all measurements do you make in your routine life? You measure the length of a line segment, the time of the day, the volume of milk you buy, the weight of fruits you buy, the temperature during the day or night to know how hot or cold it is, the speed of car or scooter you are traveling on, etc. Such quantities like length, weight, mass, time, volume, temperature, and speed that can be measured are called physical quantities. In olden days, people used different parts of their body such as a handspan, a foot, arm's length, etc. to measure length. A foot, a handspan, a cubit. Activity. Measure the length of your desk with the help of your palm, handspan. Write down the length. Also let your friends measure the same using handspan. Are the measurements of all of you the same or do they vary? In activity 2, you would have noticed that different results are obtained. This is because the length of the handspan of your friends and that of yours may not be the same. Similarly, the foot length and the cubit length may also vary from person to person. Therefore, it was felt that there is a need to have a standard set of units which could be used uniformly by everyone. Measurement means the comparison of an unknown quantity with some known quantity. This known fixed quantity is called a unit. Standard units of measurement. To overcome the above problem, the French created a standard set of measurements called the metric system. Different countries had their own units of measurement. So, for the sake of uniformity and convenience, scientists all over the world decided to accept a basic set of units for the measurement of physical quantities. This set of units now used is known as the International System of Units, SI. In this system, the standard units of length, mass, and time are meter. It is a standard unit of length. It is written as m. Kilogram, it is the standard unit of mass, written as kg. Second, it is the standard unit of time, written as. The SI system is used uniformly all over the world for all scientific work. However, in everyday measurement, other systems are still in use: the FPS system, foot, pound, second, the CGS system, centimeter, gram, second, and the MK system, meter, kilogram, second. Multiples and submultiples of units. Making calculations with very large or very small numbers is difficult. So, multiples of standard units are used to make large measurements. If you look at a meter scale or the scale in your geometry box, you will notice a number of divisions on them. Similarly, submultiples are used to make small measurements. 1000 mm equals 1 meter. M equals 2 meter. 100 centimeter equals 1 meter. Equals 2 millimeter. 1000 meter equals 1 kilometer. cm equals 2 centimeter. km equals 2 kilometer. Some rules to be kept in mind while writing the symbols of units. Symbols are not followed by a full stop. Symbols are not written in the plural. For instance, we write 100 kg, not 100 kgs. Correct measurement of length. We use different measuring devices in our daily life. A meter scale is used to measure the length of a cloth, whereas a tailor uses a measuring tape. Therefore, for measuring length, we must use a suitable device depending on the object whose length is to be measured. To measure the diameter of a tree or to measure our chest, we have to use a measuring tape, as we cannot do it using a meter scale. The following steps should be followed while measuring length. The measuring instrument must be placed exactly along the length to be measured. It must be kept parallel to the body. At times, the end of the ruler may be broken and the zero mark may not be clearly visible. In such cases, use any other major mark of the scale like 1 centimeter or 2 centimeter. Subtract this reading from the final reading to get the length of the object. Example, if you start measuring length at 1 cm and the reading at the other end is 12 cm, the length of the object will be 12 minus 1 equals 11 cm. Position your eye exactly above the point where the measurement is being taken. Activity. Measure the length of your teacher's table first with handspan, then repeat the measurement using a scale or measuring tape. Compare the two results. Ask your friend to repeat the activity. Length in handspan. Length in cm. You will see that length in centimeters will be the same in both the cases. Length in handspan may differ because it can vary from person to person. Measuring the length of a curved line. We can measure the length of a curved line using a thread. Activity. Measuring the length of a curved line, AB, using a thread. 1. Tie a knot at one end of the thread. 2. Place the knot near one end of the curved line, i.e. at point A. Press it down with your forefinger. 3. Place a small portion of the thread along the length of the line. Press the other end of this portion with your hand at point O. 4. Using the other hand, stretch a little more portion of the thread along the curved line. 5. In this way, cover the entire length of the curved line using the thread, till point B is reached. 6. Make a mark on the thread where it touches point B. 7. Stretch the thread along the meter scale, and measure the marked portion. 8. The length of this portion is the length of the curved line.